Welcome to day 3 quadratics lesson. We're going to learn about quadratic functions, which are in the form y equals ax squared plus bx plus c. That is your general equation. And this has to do with parabolas. Those are the U-shaped graphs that you see there in red and black that open either up or down. And again, your function family is a quadratic function. It has the x squared in it. What we're going to do is we're going to use our calculators in order to help us model certain things. A lot of times it's projectile motion or things being dropped. Here, the first question that we're going to have is a baseball player who hits a home run. Okay, so picture a baseball player hitting a home run. Now, when they measure the home run is actually measured in potential distance. In other words, when the player hits the ball, obviously it's going to land in the stands, but the baseball is actually measured as if there were no stadium there and it hits the ground. So we're going to do a couple of things. We're going to model the path of the ball as a parabola given by the equation up on the top right here. H of t, in other words, height as a function of time, is negative 16t squared plus 96t plus 5. Okay? Now, if it's height as a function of time, what that means is on your graph, time is the independent variable in seconds, and height, and I'll write it here on the side, H-E-I-G-H-T, is in feet, and that is your dependent variable. In other words, your height depends on the time that the ball is in the air. Okay? Some of the questions that we want to answer. Think about some of the questions that you might ask. How high did the baseball go? When will the baseball actually hit the ground if the stadium wasn't there? Or how long did it take for the ball to actually hit the stands that were 85 feet up in the air? Okay, so these are some of the questions. What we're going to do is we're going to start by answering those questions using our calculator. So I need you to take out your calculator, and we're going to go through some basic parts of your calculator. Okay, so bring up your calculator. Got a few things I got to erase here. Okay, what I'd like you to do is go to your y equals menu. If you have anything in your y equals menu, I'd like you to clear it out. So I'm going to clear out mine. I'm going to also go to my window. So there's your window. So your window button's right underneath your screen. And I would like you to just observe that we have min max. In order to change this to what I have, we're going to go to zoom, which is right next to window, and we're going to go to zoom 6. That'll get us all starting in the same spot. Zoom standard is negative 10 to positive 10 on both x and y. Okay. I also want you to go to your second, so hit the second key, and then window, that is table set. In other words, we're going to work with the table to start, and we need our table to all kind of start at the same spot. So when you go to second window, anything here in blue, in other words, table set, you have to hit the second key first. I want it to start at 0, and I want the change in table, that's what the little triangle table means, to go up by 1s. In other words, my x values are going to go up by 1s, and I want them to start at 0. Okay? All right, so what we're going to do from here is we're going to go to our y equals menu, and we're going to enter in the equation. Now, your equation says h of t. Your calculator doesn't have a t variable. Well, it does, but it doesn't use it the way we think. We want to use x. So we're going to enter in negative 16x squared. Your x variable is right next to the alpha key, the green one, right to the right there. And if at any point you need to replay the video, you can always pause it and go back and watch what buttons I'm hitting by what's being highlighted there in red. Okay? So negative 16x squared plus 96x plus 5. Okay? So enter that equation. And one thing I want to point out is the negative that's in front of the 16 is a negative sign. That is all the way down on the bottom right, below the 3 on your calculator. There is a difference between the negative and the minus. You want to use negative when the number's value is negative. You want to use minus or subtraction when you're subtracting it from something. There is a difference, and your calculator needs to understand which one you're using. Okay, so I'm going to hit graph. That's on the top right, right below your screen. And you're going to notice that I've got two lines that look pretty vertical. Now picture the path of the ball. The path of the ball is going to go up and it's going to come back down, which means the highest point is going to be somewhere up in the middle of those two lines. And it's not a very good picture, but what I'm going to tell you is we're not going to use the graph right now. We're going to focus on using the table to answer some of our questions. Okay? The table is located right above the graph button. And again, it's in blue, so we need to hit second graph, and we need to get to our table. Okay? Our table, what this means is x is time, y is height. So at time 0, we're at a height of 5. At 1 second, we're at a height of 85. Now, these negative numbers over here from 7 on, so from there below, don't really make sense because what that means is my ball is at a negative height of 107 feet. The ball stops when it hits the ground, right? So we're really looking at a window range of 0 to 6 for my x values. Now, my highest y value appears to be right here. So that appears to be my maximum. So that first question that we had in our lesson said, what is the highest the ball reaches? In our table, it looks like 149 feet. Now, when does that happen? That happens at 3 seconds because that's our x value. Now, this is a point 3, 149 that we can use to help us graph. The next question says, how long will it take to hit the ground if there were no stadium in the way? Okay, so if there's no stadium in the way, that means a height of 0 feet. So let's look back at our graphing calculator. Now, right here, so let me erase this one. Okay. Right here, my ball is coming down and it hits, it looks like at 6 seconds, we're at about 5 feet off the ground. So it looks like my ball is going to hit the ground right about after 6 seconds. So let's go back to our lesson and we're going to say just after 6 seconds. Do we know exactly? Not yet. Now, how long will it take to hit the seats that are at 85 feet in the air? Well, this again, we're going to go back to our table. That happens to be here because that's at a height of 85 feet. And that happens to be here as well because that's at a height of 85 feet. Okay, so it looks like at 1 second and 5 seconds. So go back to our lesson. So we said 1 second and 5 seconds. Now the 1 second is actually when the ball is going up in the air. And so it passes 85 feet at 1 second, but then comes back down at 5 seconds. So at the 5 seconds is actually when it hits the seats. Okay? Now what we're going to do is we're going to use some of these points to graph on our window, or on our graph here. What do I want to set my window to be? Well, think about the problem in general. The problem starts at 0 seconds, and it ends at about just past 6 seconds. So if I think about my timeline, I want to go up by ones because ones is going to be enough to kind of fit across there. If I had something that was up in the air for maybe 15, 20 seconds, I might want to go up by twos. Now my height starts at 5 feet and goes all the way up to 149 feet. So we need to think about a scale for our y-axis that's going to make sure that we see that maximum point. And I'm going to go up by 20s. Okay, so 160 looks good. So let's start plotting some of these points. We know at 0 seconds we're at 5 feet, so we're at about a quarter of the way up there. We said at just past 6 seconds was when my ball hit the ground. And we know at 3 seconds we're at our maximum of just under 150, so just under halfway up. Okay. So those are 3 points that I'm going to use then to graph our parabola. Okay. That's what our parabola looks like. Now, in theory, our parabola continues on forever downwards. In other words, it opens downwards because the arrows kind of point downwards. It would continue on forever downwards. But in the context of our problem, the ball stops when it hits the ground, and it only started when it was at a height of 5 feet. Okay? All right, so same thing. All I did was type in the answer. So you can see here, I found out that actually at 6.05 seconds is when it hits the ground. Okay? If you're thinking about when the ball was at 85 feet, that's up here in blue. So if you look up here at your graph in blue, that's a horizontal line that represents when your function is actually at 85 feet. Okay, so I put some more points on there. So take a second to take a look at this. There are some limitations, though, however, to using your table in your calculator. For instance, how long did it take before it hit the ground if there was no stadium in the way? We estimated that it was just past 6 seconds, but we know that it's actually 6.05 seconds. So the tables have a little bit of a limitation in the values that they will give you. We have seen this in the past. We learned that tables are probably the most inaccurate whereas going to a graph is slightly more accurate, but using the equation is the most accurate. We learned that before when we went through some of our linear functions and stuff like that. So um, what I'd like you to do now is take a second to look at the graph, and I'm going to stop the video here and create a new video for using the next part of our calculator functions.